Okay, so in this video, I'm going to be introducing you to volumes of revolution. So, give ourselves a nice new title of volumes of revolution. Now, in Edexcel, volumes of revolution is in the second year. They've put it in the second year of A-level further maths. So, it'll be introduced to you a little bit earlier, but the principle is still the same.
Okay, I just want to make a quick point on that. I said that when I actually filmed it, but when I'm editing this, it's in the Core Pure 1 for Edexcel, but that is doing it normally, which is what I'm going to show you now. In the second part of the video, you'll see you have to do it parametrically. So in terms of a different parameter T it usually is. So keep watching, and this is all about volumes of revolution. First bit, Core Pure 1, year 12, second bit, year 13, Core Pure 2, for Edexcel anyway, and other examples as well. So like and subscribe, keep watching.
No matter how you and when you study it. So if we take, for example, I don't know, some y and x value, and it kind of looks like the shape that I want to be drawing. It kind of looks, to me, a bit like a dumbbell. I don't know if you see what I mean by this, but it kind of looks like a dumbbell to me, the shape I want to draw. It's pretty distinct and pretty obvious what I want to do. And what we are saying is, we are finding a little bit and taking that little chunk out of, it kind of looks like a bit of a butternut squash to me, but I don't know, you can see what I mean in it when I draw a little bit in a moment on this nice lovely diagram. And we've got this rotation going around about the x-axis. So when we rotate something, okay, so zooming on that bit that chunk I've just took out, that is some delta x, like some length x, and you could find the sum of every single chunk on that line. So the sum, okay, so sigma of pi y squared multiplied by delta x.
Another quick note here is what I'm actually drawing, that little rectangle. You could need to find the area of that and add up all the areas, which is what I'm saying here, pi y squared, so finding the area and then adding up all the areas to end up giving you the massive area, and that will end up finding the volume, which we'll look at in the next few minutes. So keep watching. Again, sorry for interrupting the whole video, but I thought if we want to a polished video, I might as well edit this as I go, so keep watching.
X. So as delta x will tend to 0. Okay, your volume, as that will tend to 0, I end up with the integral, which is where I'm putting it in the integration section of this course, between the limits a and b, okay, of pi y squared in respect to x. Now this is for a rotation about the x-axis, okay? So if you're rotating something about the x-axis, you want to be using this format. However, if you want to integrate something, I don't know, find the volume is the integral, let's just pick some different limits, p and q, for example, just to be different, of pi x squared dy. So this, you are just flipping what we've got here in here, okay? So that's all we do. And for this one, it's rotating about the y-axis. Okay, so that's a rotation about the y-axis. So it won't be this, it would be this just on its head. So turned on its head, and it would basically be the same thing. So you'd have some sort of, I don't know, kind of looks like that to me. I don't know, but it's basically this just turned on its head. Yeah, it could be modelling anything at all, but you've got that little ring that I was talking about earlier, and it means the same thing. some little chunk, which I'll call delta y. Okay, so as delta y will tend to 0, we end up with this. Okay, and that is the basics of volumes of revolution. So you're taking little chunks, and as those chunks get bigger and bigger and bigger, we can hence find the integral by finding the volume. So the summing of everything to hence find the volume for either something as simple as rotating about the x-axis or about the y-axis. You have to remember which one to use, so don't use the wrong one. And it'll be pretty obvious because your function will be y equals or x equals. If it's y equals, then you probably want to be doing this one. If it's x equals, you probably want to be using that one. Okay? So in the next part of this video, we're going to look at examples of volumes of revolution. Alright then, so here's an example. We want the region between the curve y equals x squared, the x-axis and the lines x equals 2, x equals 4 is rotated 360 degrees about the x-axis. Find the volume of revolution. So if we drew some sort of curve to support what we are doing, we could draw the nice simple curve of x squared, which is kind of like a U shape, if you will. Okay, I'm going to draw part of it, and I want to be drawing that between 2 and 4. Okay, so we're going to get hopefully a very large value because that's what we want. The lines x equals 2 and x equals 4, and the x-axis. So rotation about the x-axis, we need to make sure that we are using the right form. So I'm integrating between 2 and 4. Now, is it pi y squared or is it pi x squared? Well, it's pi y squared. Why? Because my function is in terms of y equals, okay? So I end up with pi y squared in respect to x, okay? Which is equal to the integral between 2 and 4 of pi y squared x squared, so x squared squared, okay? In respect to x still. Now, I like to bring pi out the integral. I don't know if that's with you as well, but that's pi times the integral between 2 and 4 of x to the 4 in respect to x. I can now integrate that and evaluate it. So adding 1 to the power will get me x to the 5, divided by that will be 1/5 x to the 5, evaluated between 2 and 4. So I now end up with pi multiplied by, let me just find my calculator. Okay, calculator found, Casio class list. I'll still be using the Casio class list in the available further maths teaching videos for all videos to come, by the way, in case you're interested. So we're going to be summing in 4 first of all, so we've got 1/5 of 4 to the power of 5, isn't it? Which is 1024 over 5. Okay, and then I want to be subbing in the 2, which is 32 over 5. Okay, and then I want to be multiplying that by pi as well, don't I? So I get 992 pi over 5. Or you could write it as 992 over 5 pi, like that. That would also be acceptable in an exam, but that one is my preferred one because I like everything in one simple fraction, okay? And that is how we can find the volume of revolution for this question. Okay then, another example then. We've got y equals e to the 3x, x equals 1 and x equals 3 is the region that we want to find here. And it is rotated 2 pi around the x-axis. Question wants us to find the volume of revolution again. Okay, now if we rotate about the x-axis, so we need pi y squared, don't we, when we're integrating this between 1 and 3, because those are technically my limits, but they're kind of hidden, if you will, of pi y squared in respect to x, and that is the start of my integral, which is the integral between 1 and 3 of pi. Now y squared will be e to the 3x squared. Okay, so just be careful of that. So I end up with that. Now e to the 3x squared, you have to be careful because it is still the same. I'm going to bring pi out the integral between 1 and 3 of e to the 6x in respect to x. Just because I like to bring pi out the integral, I don't know if that's for you as well, but for me, that's how it is. Now, integrating that, it pretty much is the same for it's the same for pretty much any integral that you do with e. E doesn't change. It's one of those nice ones that don't change. If you learn that at A-level maths, you will learn the integrals of those to be pretty standard. So we want to sub in the 3 first then. Subbing in the 3, we'll get 1/6 e to the 18, is it? We'll leave it in exacts form, so I don't need a calculator for this. Got 1/6 e to the 6 because summing in 1 is very nice and easy. The 1/6 will cancel, so I get e to the 18 minus e to the 6. Okay, now that will be. Oh, I've got to bring pi out as well. So I'll bring in that out. But you need to bring the pi out 6 out of the integral. Now, you could be nice and divide through by 6, I suppose. So we get pi over 6 of. Now, this is going to be e to the 12. That'll be divided by e to the 6 will get me 1, because divided by itself. And then multiply it out by e to the 6. It doesn't matter how you leave your answers if it says it in exact form. This question doesn't specify, so it doesn't really matter how you want to leave it. I prefer leaving it like that because it's nice and standard. And if you were wondering, all you are wanting is the integral between 1 and 3 of pi times e to the 3x all squared. Okay? And that is how we can find the moment of revolution for this question about the x-axis. Okay then, so we've got another problem rotation about the x-axis. Again, I want to throw this one in, bit funny one. So we've got y is equal to the square root of 2x over x squared plus 3, which is rotation about y equals 0. Find the volume of revolution. Now, what's y equals 0? Well, y equals 0 is all these points here. Well, what is this line called? The x-axis. So it's just another way the exam board can trick you, okay? So this is one thing, a rotation about the x-axis. So, and as well we've got it as y equals, so I don't think you'll be rearranging that. So we've got the integral with time between 0 and 1, the limits here, of pi y squared dx. Pretty standard. Okay, which is equal to the integral between 0 and 1 of pi. Now y squared is this squared, which looks pretty nasty, but it's not because the square root will cancel. So I left it with 2x over x squared plus 3 in respect to x. Now, integrating that is pretty damn nasty, but if you remember the log trick from normal single level maths in second year, you will have learned basically the integral trick, which says that f prime over f of x in respect to x. To find that is just the natural log of the function modulus plus constant. Okay, that is one that I suggest everyone learns. It's a standard pattern that you have to learn. I find it's helpful for everybody, but it's just ln of the bottom, which is ln of mod of x squared plus 3. Okay, nice and simple. Evaluated between 0 and 1. I'm right at the edge of the board there, I do apologise for that. Now, let me sub these in, so I don't need a calculator for this one. I've got ln of 1 squared plus 3, which is 4. We've got ln of 4. Well, ln of 0 squared is 0, so I get minus ln of 3. Okay, now using the log laws, which is first year A-level maths. So the log law tells us that ln of b minus ln of a, so we're taking logs the same as ln of b over a. Okay, so that's the other law that you have to learn to do this question. So that'll be ln of 4 over 3, okay, using that log law there. Okay, so we're using what we know from single maths in order to bump it up to further maths to make it a bit more interesting, okay? So that was a nice problem to do, but I don't know, it might criticise me. But that is how we can find the volume of revolution for this specific function. Okay, so I've got another problem here. We've got y equals the square root of x e to the minus x, which is rotated 2 pi around the x-axis. Find the volume of revolution, and we've got x is 0 and x equals 1. Okay, to do this problem, you need to know how to integrate x e to the minus x. Now, integrating that, I have to use integration by parts, because I've got a piece of algebra and I've got an exponential. Okay, so I'm using the late rule. Should know what the late rule is. I've got logs, algebra, trig, exponentials. That's the way I remember it to find out which is me, going to be my u here. Using the late rule, my u is going to be the algebra bit, which is the x. Okay, so the u, I want that to be the x. And the dv by dx then will be that e to the minus x bit. Okay, so integrating to find v, or integrating that doesn't really change, does it? Let's get minus e to the minus x. Okay, and my du by dx over here, well, that's going to be 1. Okay, now I'm set up and I can do my integral. So I've got the integral of pi over y squared evaluated between 0 and 1, which is equal to the integral between 0 and 1 of pi y squared, which is x e to the minus x. So squaring and squaring is the opposite of each other, so they cancel. And that is in respect to x. Okay. Now, there's sort of 2 ways I like to go about this, because there's using integration by parts, which means I need to kind of evaluate this a bit better than kind of what I've done. So I've got minus x e to the minus x, which is that first little bit that we did, by the way, between 0 and 1. But then we've got to add this other integral bit between 0 and 1 of e to the minus x with respect to x. Okay, so it's a little extra caveat, but it doesn't really change the process of the integration. So I want to combine these together into one single one. So I've got pi of x minus x e to the minus x. Okay, and I'm taking away e to the minus x. Okay, divided between 0 and 1. Make sure that's an actual square bracket and don't look like a curve, which is pi times the so I need to sub in the 1 first, so I got minus e to the minus 1 minus e to the minus 1. Okay, and I'm taking away, well, that's going to be 0, so that's gone. And that is going to be e to the 0, which is 1. Brilliant. So I end up with pi times 1 minus 2 e to the minus 1. Yeah, which is my volume of revolution. Okay, and that is how I can integrate using integration by parts with volumes of revolution. Okay, back to volumes of revolution, and I've just dropped my pen lid, as I do. So, we want to find the volume of the sphere rotated about the x-axis. Now this is a quick proof, and I want to prove to you the volume of a sphere, which at GCSE you should have seen. Now I won't tell you the result because I expect you know it. So I'm going to dive straight in, and you can see quite easily where this will come from, as it will be rotated about the x-axis. Now, the volume of a sphere is like a circle, like bounded a bit, isn't it? So if we start the equation of a circle, which we've seen previously in single maths, go x squared plus y squared equals r squared. So what would y squared be? Well, y squared will be r squared minus x squared. Okay, that's it. That is literally it. And all I've got to do now is integrate. So I've got the integral. Now, what I'm going to use as my limits? Well, if you think about it, I've got like my little circly thing going on. Like, I want this bit, don't I? Well, what do I know? Well, I know this is a negative radius. That's a positive radius. Negative r, positive r. Okay, so that's what I'm going to integrate between minus r and r. Like, how fun is this? You might not think this is fun, but I personally do. With further mathematicians, definitely should. So I've got pi of the integral between minus r and r of r squared minus x squared. Now, this is going to be in respect to x. Now, you might think I can't integrate r squared in respect to x. Well, you can. Let's look. I've got bring the pi out of the integral, as I usually do, of r squared x. It's funny, but it does work. It works like a constant term, because don't forget your r squared is a constant, right? Minus 1/3 x cubed. Adding 1 to the power divided by the new power value weighted between minus r and r. So I've got pi lots. Now I've got r squared times r, so that'll give me r cubed. Okay, something in the top limit. And I get minus 1/3 r cubed. And I will take away this bottom limit. Now, taking away minus r times that, which will be minus r cubed. Minus times a minus, so I get a positive third r cubed. Somebody proved this really nicely in an exam, but they forgot that the last bit said that you need to put a positive instead of a negative. Yeah, we don't talk about that anymore. So I've got pi, this seems pretty explicit, of now how many r cubes do I have? Well, I have r cubed minus a minus, so it'll be a plus, so I get 2 r cubed. Seems like it actually works, it's awesome, isn't it? So I get minus, so I'm going to get 2/3 pi r cubed. Now, 2r cubed plus 2/3 r cubed will get me to 4/3 r cubed times pi. Well, it'll just be 4/3 pi r cubed. And funnily enough, that is how to find the volume of a sphere that you know from GCSE. And I can bring it up into my A-level knowledge and put it into this video. Okay, so it's quite nice, and there you go. So that is how you can find the volume of a sphere, and that is where the formula comes from. Okay, so this problem I've got y equals x squared plus 4 as a function, so that's just x squared shifted up 4. Y equals 4, y equals 5, and the y-axis. If rotated 360 degrees about the y-axis, find the volume of a revolution. Okay, what can I do with this then? I know what I'll do. I'll start off with my integral stuff between 4 and 5 of pi x squared dy. Now, we don't know what pi x squared, we don't know what x squared is, do we yet? Well, I could, because I can rearrange. So rearranging, I get the integral between 4 and 5 of pi, or in the pi out the integral, so it'll be y minus 4 dy. Okay? You cannot put pi x squared dx, pi y squared dx, you cannot do that. It will just not work. Pi y squared, because it's rotated about the y-axis, so it'll be pi x squared. Okay? funny, but I've seen it in Mark's games, and it rejects it. So make sure you do what you should. Oh, it's between 4 and 5. So let's sub in my limits then. Got 1/2 times 5 squared minus 4 lots of 5. Take away 1/2 times 4 squared minus 4 lots of 4. Okay, so that'll be 25 over 2. Take away 20. Take away 8 minus 16. Okay, which is pi times minus 15 over 2. Plus 8, is it? Yes. Okay, which is be 1/2, won't it? So it'll be just pi over 2, or 1/2 pi. Okay, because the reason why I draw my coordinate plane, as you've seen in previous videos in the past. Okay, so that is the whole reason of the points of revolution with this problem, because it's rotation about the y-axis, not the x, as in the previous example would have been. Okay, that's it. Okay, so in this video we're going to look at the shape of a vase can be shaped level by rotating the curve with the equation 10x squared minus 2 lots of y taken by 3 squared equals 40. So swing y equals 0 and y equals 6 about the y-axis. Find the volume of water measured or required to fill the bars in your answer as an exact value. The exact value is important because it means we can't just shit it all in our calculator, if you will. So I need to rearrange all that lot. So 10x squared. Now, how do I want to go about this? Now, I'm going to use the rotating about the y-axis formula, but I need to get it rearranged into a form that I can physically use. And I need to expand that bracket out. I get 40 plus, that'll be 2y squared, and if I'm multiplying all of it by 3, I'll get minus 12y. That'll be plus 9 times 2, so plus 18, goes there to plus not negative. So I end up with that. Now I just collect like terms, put everything onto one side. It's 40 plus 18, which would be 58, won't it? So we've got 2y squared minus 12y plus 58 is 10x squared. Now we need to get x squared, so I'm going to need to divide by 10. So I'm going to get 1/5 y squared, so 10 minus 12 over 10, which is 6 over 5 y plus 58 over 10, which is 629 over 5. Okay, so we've got a replacement for the x squared. Therefore, the volume will be equal to pi times the integral. Now your integral is x squared dy between 0 and 6. That's my integral separate. So we need to bring that 5th out the front. I don't fancy leaving that in, so we've got pi over 5. I don't feel like leaving that integral in between the 0 and the 6 of x squared, which was this. Now, because I brought that 5th out, it makes it a hell of a lot easier because I can essentially get rid of that, and I just get left with it. Okay? So I get pi over 5. Now pi over 5 is that, so I need to integrate that now. So I didn't want to pound divided by the new power, so we get 1/3 y cubed. That'll be minus 3y squared. Yes. Plus 29y. Evaluated between 0 and 6. Okay? So I'm just going to go and fetch my calculator. So Casio class was fx991ex, of course. So we need to sub in the 6 first of all, don't we? So we've got 1/3 times 6 cubed minus 3 lots of 6 squared plus 29 lots of 6, which is 138. And if I sum in 0, I just get 0. I can do that bit in my head. So I need to 138 times that, which is 138 pi. And that is the exact volume of water required to fill that. That's the end of this video. Make sure to like and subscribe, and I shall see you all in the next video, where we're going to be looking at integrating using the inverter.